We're going to solve problems involving quadratics. So we have a very long problem here. We need to try to make sense of it. Since the cost of running an assembly line is a function of the number of items produced per hour. In other words, your cost changes depending on how much of an item you produce. It makes sense, right? Materials, time. The cost function, so our cost is C at x, is modeled by this equation, where C at x is the cost per hour in thousands. So per hour, when we figure it out, so if this cost ends up being 5, that's going to be 5,000 per hour. That's how much I should get paid of dollars. And x is the number of items produced per hour. So x obviously is the number of items. Determine the most economical production level. Okay, so because we know this is a quadratic, there are some major things we can talk about. Let's say we're graphing this. Let's draw a quick sketch of something like this. The A value of this is what? Yes, okay, well, I'm actually more looking for the operation. Is it positive or negative? Positive, which means it's going to open which way? Up. Yes. So, if we're talking about cost, okay, this is our C at x, and this is our x, the items produced. For us, what will be the most economical cost? At what point along that graph? The vertex. And why is that? It's going to cost us what? It's going to be the least here, right? We don't know if it is 0, okay? We just know that it'll be the least at that level. So what we're going to do is we're going to try to figure out exactly where that level is. So we're going to take this cost function, C at x is equal to 0.28x squared minus 1.12x plus 2. Now what form is this in? Okay, and what would be the quickest route to find the vertex?
Vertex factor.
Factor will take longer. There's a faster route. Quadratic will find what? The roots. Do we even know if there's roots?
No.
We don't. You're right, we could do the discriminant. You guys want to try that quick? Let's do the discriminant and see if there's any of those. But really, what is, before we actually go into that, what would be the fastest way to go from standard to find the vertex? What form gives us the vertex? Vertex form. So how do we go from standard to vertex form? What's this called? Complete the square. Okay, so completing the square is what we really want to do. So that's a great idea. Let's actually check though before we go about completing the square if there are any x-intercepts. Because at that point, what that'll mean is our production or our cost of production will be what? If we have x-intercepts? 0. That'd be amazing if our cost of production is 0. Okay, which means it's probably very unlikely. Let's use our discriminant to find this. So D is equal to what? What's the formula? Yeah. Good. What is our B? Negative 1.12. And we'll have to square that value. Okay. Is equal to minus 4. What's our A value? 0.28. And our C value? Who's right? Thank you. Let's get our calculator out here. So because it's a negative, we know it's going to be a positive answer, so I'm just going to type it in as a positive. Squared, 1.2544. 1.2544. Now let's subtract this. So 4 times 0.8 times 2, 1.6. So what are we getting?
A negative number.
We're going to get a negative value, which means there are no roots. So at no point is cost 0, which makes sense. If we're a company, it'd be amazing if it cost us nothing to produce things. We're making pure profit. So what we do need to find, though, is the lowest value, and the lowest value is going to be the vertex then in this case. This has no x-intercepts. What did I give you?
You only multiply by 0.8. 0.28.
Oh, let's see.
You're supposed to get 2 point something.
2 point something?
1.12.
4 times 0.28 times 2. Okay, well, it's... All right, so I made an error here. Way to go, Jerwin. Excellent job. But we still get a negative. It didn't change anything in terms of our theory. So let's actually go about this now.
Did you catch that or Jake?
Way to go, Jerwin. That was great. So if we're completing the square, what is our very first step? What do we do? What's our first step for completing the square?
Factor out A
Yeah.
from the first two.
That's right. We're going to factor out our A value from the very first two, right? So in other words, we're going to divide both of these by 0.28. Okay. So that's going to come to the outside. We have our 0.28 as our common. And we'll have x squared. And what will this value be? Let's do some mental math, Jerwin. And what is it?
4.
You're good at mental math. So 4. Beautiful. Plus 2. Okay, what's the next step to completing the square? Mitchell.
B over 2 squared.
All right, b over 2 squared. And not just the original b, but our new b. So, Jake? Because when we're completing our square here, with our vertex form, remember we're going to have a perfect square trinomial. So we're only doing it to the first two. This will help us figure out what the actual y value of the vertex is. Okay? So we have 4 divided by 2 squared, which is going to be 2 squared, which is going to be 4. What do we do with that 4? Just plug it in. Where do I plug it in and how? That's right. We need to add and subtract 4 in the brackets. So it's the same as essentially doing nothing. And then what do we got to do?
Multiply by 0.28.
Yeah.
Excellent. It's a lot of mumbling.
I don't know how I know this, but I'm going to quiz. Jeez.
Okay. Who can help me with a calculator here? What that's going to be? X plus 4. When it comes outside, 4 times 0.28, 1.12. What a surprise. And it is actually going to be negative 1.12 plus 2. Right? We then got to factor this. We talked about the fastest way will just be to find the roots of these two values. So that will give us x2. We know it'll be squared. And we take the operation of the middle term, so it'll be negative. So 0.28, x minus 2 squared. And when we equate that, what do we get?
Plus 0.8.
So, let's make sense of this information now. Okay? We need to make sense of the information here. So, our production level, or let's talk about what is the vertex. What's the actual coordinate of the vertex, Mitchell?
2, 0.8.
Okay, 2 and 0.88. Okay? Now let's talk about this is our x, this is our y. We'll jump up to the original question. Our cost per hour was in thousands, which means that's our y value. So to actually find out what our real cost was here, what do we do with this 0.88? Times by 1,000. So we get 1, 2, 3. Yep. 880 what? Dollars per hour. For how many products though? Let's see. And X is the number of items produced per hour in thousands. So how many things do they produce? They produce 2,000 vests, let's say. We're saying they're making vests. So it costs them $880 per hour to produce 2,000 vests per hour, and that will be their most economical